Hello friends, hence this video lecture is about the trigonometry, basic trigonometry concepts which we dealt with in the class. So those who could not attend the class or those who want to revise the concepts, this video would be helpful to them. So what we learned in basic trigonometry was that there is a triangle and there are three sides to the triangle, and depending upon where we choose the angle, there are opposite as well as adjacent sides defined. And then since there are three sides to a triangle, we take ratios two at a time. So ratio is nothing but the ratio of the lengths of the sides of the triangle. So since there are three sides, there could be six possible ratios. So let's get into the details. So what we did was even before we took up the triangle, we drew a circle, and we took that O as center and OP as the radius, and we drew a circle with radius OP. In this case, we have shown that the radius is of 5 units. You can see it here. Now, once we are done with the circle, we take a point P anywhere on the circumference, but making sure that P is on the circumference and P is not allowed to leave the circumference. Now, from P, we dropped a perpendicular PQ onto the x-axis, and we joined OQ. So basically, we get a right-angled triangle OPQ, and angle OQP happens to be 90 degree in this case. Okay. Now, so in this right angle triangle OPQ, we have got six ratios depending upon which sides we are taking. So first of all, let's see what all are the sides. How are we defining the sides? So if this angle is theta, in this case it's shown as theta 1. I can very well rename it as theta. Let me rename it as theta. So okay, so in this case this is theta, and in this here it is shown as 56.35 degree. Let me take some common value. Let's say this is 30 degrees. So 30.28, or let's say whatever, so that all those labelings are clear. So this is P. So this P is nothing but the perpendicular length PQ. B happens to be the length of the base OQ, and H happens to be the length of the hypotenuse OP. Now 1, 2, 3, 4 denotes the four quadrants in which we have divided this plane. And right now angle theta, which is always measured from x-axis away from x-axis in anti-clockwise direction, anti-clockwise direction is taken to be as positive theta. So hence in this case it is shown to be 30.11 degrees. Now in this, coming back to the triangle POQ, we have three sides OP, PQ, OP, PQ, and QO or OQ. So basically P, B, and H. So taking two at a time, if I take P by H, I'll get one ratio. In this case, it's been shown that the length of P is 2.51, B is 4.33, and hence the ratio is 2.51 upon 5. So in this case, the ratio is P upon H, so 2.5 upon 5. Similarly, we can have B by H, we can have P by B, we can have H by P, H by B, and B by P. And if you noticed, we have provided six names to these ratios: sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Now, question could be asked: why are we mentioning theta along all these names? We could have named them with any other names as well, but then theta is assigned to all of them, and which is to express that all these ratios are dependent on the angle theta, the choice of angle theta. If I change the value of theta, and we'll see in a while that all the values start changing. So let us change the theta values. So now I'm moving away from point E and I'm going in anti-clockwise direction. So now if I keep it here, the theta value has changed to 61.96. If I change it to here, it has changed to 79.79. So if you noticed, when I'm here, see the ratio 4.92 upon 5.98. The moment I reduce theta, if I reduce theta, this ratio reduces, but this one increases. Similarly, let me reduce it further. So if you see, this is getting reduced and this is getting increased, and similarly all other ratios are being altered. So I'm not touching the radius at all. I'm just changing the theta, and as I'm changing the theta, the value of the perpendicular PQ and the base OQ are changing. Just see once again. So if I'm increasing the theta, if you noticed, the value of value of P as well as B is changing, H remains the same as the radius is not going to change. So if you see, as I'm changing the value of P and theta, as theta is increasing, P is increasing, but B is decreasing, and here are different values. So you can see, as you are changing the value of P, the value of, as you're changing the value of theta, the value of P as well as B are changing. So hence, we can very well say that all these ratios are dependent upon what is the value of theta. So if this is the theta, right now, as I can show you, this is 15.36. Then in that case, the ratio PQ upon OQ, which is named as sine, and hence sine of 15.36 gives you a value of 0.26, right? Similarly, if I increase the value of theta to 25.74, so when theta is 25.74, sine of that is, and we have defined sine as opposite by hypotenuse. So if you see, there are other ways of defining them as well. So first of all, let us understand what is meant by opposite side, hypotenuse as well as the adjacent side. So if you take this as theta, there are two possible adjacent sides to it. Adjacent side means the side which contains the angle theta. So let's say this is the angle POQ. So PO and OQ are the adjacent sides. Now in trigonometry, we consider the shorter one between the let's say one of them is the longer one. So the shorter one becomes the adjacent side, and the opposite side is that side which is intersecting both the adjacent sides. So if you see, PQ is cutting OP at point P and cutting OQ at point Q. So hence, PQ becomes opposite side and OQ becomes adjacent side, and OP, it's hypotenuse. Now, if instead of POQ being theta, if we take this theta, that is angle OPQ, then for this theta, adjacent side would have been PQ and opposite would be OQ. Okay, so once you know what is an adjacent and what is an opposite side and what is a hypotenuse side, you can take all these three ratios in terms of opposite by hypotenuse as well. So sine theta is defined as opposite by hypotenuse. Why? Because P is opposite and H becomes hypotenuse. Similarly, all the six ratios can be defined in terms of opposite and hypotenuse, or opposite, adjacent, and hypotenuse. So now when we have defined six ratios and we also understood that these six ratios depend on different theta values, we have calculated some standard values of or these ratios with some standard values of theta. For example, we have calculated all the ratios when theta was 0 degrees. So let's try this out. So to make theta 0, I have to do what? I have to take OP towards let's say OE. So let's say if I'm moving it towards O, let's say this is my P and I'm moving it on Q. Okay, if you see, it's very close to 0. So if I am now zooming in and I'm trying to, yeah, so this is my, so I have just shifted P in such a way that now P sits on Q. So obviously when P sits on Q, the perpendicular length PQ or P becomes 0. So if you see, perpendicular is 0, B has become 5. Can you see that? Which is equal to the radius. So hence, my sine theta, which happens to be opposite by hypotenuse, becomes 0 upon 5 is 0. So if you check, we have put 0 over here. Now, cos theta will be adjacent upon hypotenuse. Now, our adjacent was side B. So B has become 5 and H was 5. So 5 by 5, 1. So I have mentioned 1 over here. Now, tan becomes opposite by adjacent, 0. So opposite was 0 and hypotenuse is, adjacent is 5. So 0. Now cosec was reverse or reciprocal of sine theta. So if you see, it has become 5 by 0, which is infinity, right? Or it's shown as infinity, but it's not defined. Any number division by 0 is not defined. Similarly, sec theta was hypotenuse by adjacent. So hypotenuse is 5, adjacent has become 5, so it has become 1. Cot theta was adjacent by opposite, so adjacent was 5. Opposite is 0, so it is again undefined. So if you see, all these numbers are here. Similarly, if I take theta to 90 degrees, so what do? I need to change the value of P, or the position of P, and I have to take it to this point. Okay, right? So I have taken it to, yeah, so this is the point P. So it shows 90.26. Let me try to get 90-degree exact. Okay. Um, oh, so I'll try a little bit more by zooming it. Okay. Yeah, so this is exact 90 degrees now. So when theta is 90 degrees, if you see all the ratios, what have they become? So in this case now, perpendicular is coinciding with the radius, right? So P is now on top. So the perpendicular length is equal to radius now. So hypotenuse and opposite length have become same. Hence, 5 by 5 will get 1. If you see, P has become 5. Similarly, Q has now just shifted on to uh, Q has shifted on to, let's say, O. So Q is coinciding with O. So hence length OQ, which was our base, has become 0. So hence cos theta has become 0. Why? Because adjacent, which is base in this case, is 0. So 0 by 5 has become 0. In this case now, again, since B was 0, so anything divided by 0 will become infinite. If you see, not infinite, undefined, but since, the a huge number is possible if I divide any number by 0, so the software is throwing you this number. It's huge number, and it's almost closer to infinity. So now, um, so we saw the ratios when theta was 90 degree. So let me take any intermediary angle. So this is 45.8. I am trying to get closer to, let's say, 45. Let me see if we can achieve that. So this is 46.11. So I can go a little bit down, 45.53, and okay, no. So I might not be able to get exactly uh, 45 degrees, but let me just try once more. Not so difficult to find out exact 45 degrees over here. Anyway, so let it be 45.03. So if you see, in this case, it is 45. So by angle sum property, the angle OPQ also needs to be 45 degrees, equal to 45 degrees. So this triangle becomes isosceles right angle triangle. So in that case, OQ will be equal to PQ. And so adjacent side will become equal to opposite side, right? So the moment adjacent and opposite are same, can you see tan theta, which is now 45 degrees, will become 1. Let us find where exactly it is tan. So sin tan theta, when theta is 45, it is 1 over here, correct? Similarly, if you see, sin 45 is opposite by hypotenuse, which is coming out to be 0.71, which happens to be 1 upon root 2. So here it is, sin 45 is 1 upon root 2. Similarly, cos theta is, in this case, theta is 45 degrees, so cos theta is 1 upon root 2, which is 0.71. So basically, if you see, adjacent and opposite are same. So in this case, sin theta and cos theta are same. Similarly, in this case, reciprocals of sin theta, that is cosec theta, and of cos theta, which is sec theta, are same. The values are same. So this is how we have calculated, for different values of theta, 30 degrees, 45, 60, and 90. We have calculated the 6 standard ratios, and the table has been given over here. One question could be, what happens if theta goes beyond 90 degrees? So let's see what happens. So let's say if theta is in second quadrant. So again, we can drop the perpendicular PQ from there as well. In this case, what happens is my hypotenuse is not changing any value, but if you noticed, the base has become negative. Yeah, in the sense, now since we are in the negative side of x-axis, so the opposite side carries a value of carries a negative value. So you can see that's 1.96 over here. And now theta is more than 90 degree if you see, right? So in this case, everything remains the same, only the base value gets a negative sign. Now when theta travels to the third quadrant, or P is in the third quadrant, so if you see now, both perpendicular as well as base, or the opposite as well as the adjacent side, are negative. Why? Because it is in negative x and this one is in negative y. So both of them are having negative value. So sine and cos gets negative, but tan, negative by negative, becomes positive. So if you see, you can play around with this, and if you see different points, if I take now when it is in fourth quadrant, again the base, the adjacent value is positive, but the perpendicular value is negative, and hence the ratios are changing. So hence theta can take any value, and for all the values you will get uh, all the six ratios, negative, positive, depends on where exactly in which quadrant theta lies. So if you know this, your basic understanding of trigonometry is clear, and then you can solve many problems, especially resolution of vectors, and let's say it will be used in kinematics a lot, it will be used in Newton's laws, and till you pursue science, let's say till +2, you will be using trigonometry extensively. So it's advisable to do it as many times so that all these values you get it by heart, and all the ratios you know what exactly they mean, so that it will be helpful for you to solve higher order problems later on. Thanks a lot.